Hello, everyone, and welcome to another Mini Sky Tonight. So one of the questions I often get during planetarium shows is, why is Pluto no longer a planet? And so I decided to kind of go in depth as to why the astronomical community changed its mind and demoted it to a dwarf planet, to go about some of the history behind it, some of the newest discoveries we have seen, as well as an explanation as to why this beloved planet that we often called the ninth planet is now a dwarf planet. So our solar system, at least from when I was growing up, some of you younger audience members may not remember this, but there used to be 9 planets. It used to be Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. I always remember the fun little saying of, my very energetic mother just served us 9 pizzas. And I always loved that. But now that since we had to get rid of Pluto, it's my very energetic mother just served us noodles. Not as appetizing as the 9 pizzas, but... So why did we demote this planet that had been a planet for several years to the status of dwarf planet? I mean, the concept of Pluto being a planet has been ingrained into our culture, from different works of art, from literature to television shows, and many things other. I mean, in fact, the Disney character Pluto was named after the planet, because this character was designed and created around about the same time the planet Pluto was discovered. And so just to show the support of the astronomical community, Disney named their character after the new planet. So it has been ingrained into our culture to be able to have this 9th planet. In fact, one of the fun little history facts that I always enjoyed is that it was originally, if you remember all the Gustav Holst's planet suites, basically every planet had its own song. It was then commissioned by Colin Matthews to create the next movement of Pluto. So even Pluto got to have one of the planet suites, even though it's now just recently demoted. So why did it get demoted? I mean, this concept has been a sticking point for a lot of people. In fact, even the director of NASA has gone on record saying he still thinks Pluto is a planet in his heart, and has caused a lot of controversy and a lot of arguments between people. So let's go back into the history of how Pluto was discovered and understand some of the basics. So many people have known through thousands of years of some of the different planets. In fact, the term planet means wanderer, because they looked like stars that wandered among the heavens over the course of several nights. So we knew about Mercury, Venus, Earth, Mars, and Jupiter. Because of obviously Earth, we are standing on it. We were aware that we were on a body in space, and we saw the bright lights of Mercury, Venus, Mars, and Jupiter, and Saturn in the sky. But it was the other outer planets that we didn't discover until much later. And it had to do with the basics of calculations, understanding mathematical concepts of gravity, as well as orbit timings and things like that, to visual confirmations. For example, the discovery of Uranus happened in 1781 by William Herschel, where he discovered the planet. And using calculations, he was able to figure out its orbit and everything. But he noticed the orbit was off, as though something was gravitationally tugging it to prevent it from being able to reach a certain point in the sky at an exact amount of time. And it's through those calculations that they predicted that there was another planet beyond the orbit of Uranus. So they did some further studies, and it was in 1821 that Alexis Bouvard basically figured out, okay, the object is going to be around about this area in this time. And in 1943 and 1946, these two astronomers confirmed the discovery of the planet Neptune. But then they noticed some unique calculations as well, that even Neptune's orbit seemed off, as though something was tugging on it as well. So what could it be that caused it to not be able to reach a certain point in the sky? Because we all know that objects orbit at a certain distance with the gravitational force of the sun. So if something is a little slower, that means there's something gravitationally pulling on it out in space. Because in space, the only thing that can control whether something goes faster or slower is if something hits it or something pulls on it. And in this case, gravity. So that meant something was tugging on Neptune and we didn't know what it was. So it began the search for the next planet out there. And the first one to jump on board to try to find this 9th planet was Percival Lowell. He searched and searched and searched and searched, and sadly, he was unable to find it over the course of several years before he passed away. But fortunately, his work was not in vain. He had a college student who was one of his apprentices. His name was Clyde Tombaugh, and he continued Lowell's work. So for you college graduate students out there, don't think you can't discover something amazing. This was a college student, an undergraduate student, and he discovered Pluto. So you do have potential of doing amazing things. So don't sell yourself short. And he spent several nights looking over basically photographs of the night sky to see if something moves. So instead of depending upon your eye to see if something has changed over the course of several nights, you use a camera. In this case, what he had was photographic plates and what was known as a blink comparator, because they didn't have digital images to where they can basically flip through a bunch of images really quickly. All they had was photographic plates, and these were huge photographic plates. Just to give you an idea, this was the telescope on the left that discovered the planet Pluto. And that metal frame on the back there is where you literally stick like a portrait frame of a photographic plate. And you slapped it on there, shut the window, and you let the night sky expose the photographic plate. And then you take it out, put it in a processing room to get an image. So these were not something tiny, as you can see in this image of Clyde Tombaugh. They were huge plates, and he had to take one over the course of several nights. We're talking months at a time. And it was in February 19th of 1930 that he finally confirmed that Pluto is out there. And here's basically what he discovered. Between January 23rd and January 29th, he noticed a tiny little dot had moved. Now imagine having to do that for each individual star in the frame, marking it off and trying to see and compare it. And the way he did it was using this blink comparator. The blink comparator, basically you look in the little eyepiece in the center right there, that little gold eyepiece in the center, and it basically allowed you to take a look at an image, and then the lever that's on top allows you to basically go flip and flip and flip and flip. I often joke around saying it's basically like going to the eye doctor. Is it better 1 or 2? 1 or 2? And imagine having to do this for several photographic plates, because you don't compare 1 to 2 and then 2 to 3. No. You compare 1 to 2, then 1 to 3, then 1 to 4, then 1 to 5, then 2 to 3, then 2 to 4, then 2 to 5, and so on. So it was a long, tedious process of comparing different photographic plates. And ultimately, he saw that tiny little dot move. Just to give you a comparison of what that dot, that's what he saw. Just that little dot going, ee, ee. That was it. And that was Pluto. And he discovered it. So after doing some more discovery and some more calculations, it was the farthest planet from the sun, although sometimes it's the 8th planet. And we'll get into the reason why it's sometimes the 8th planet. It's the smallest planet in the solar system, even compared to Mercury. And it was named after the Roman god of the underworld. Many people wanted to name it for Percival Lowell. Many people wanted to name it after Clyde Tombaugh. There were several organizations at the time. I think Henry Ford threw his hat into the mix, wanting to name it after Henry Ford because he wanted to toss a bunch of money that way. But here's something inspirational for you kids out there. Venetia Bonet was an 11-year-old girl, and her grandfather was in the scientific community. And he was pondering with a couple of his colleagues as to what they should name the planet, because they were getting interest from one group to name it after Clyde Tombaugh, another interest group that was trying to name it for Percival Lowell. And then, of course, you had all the industries that were trying to get their names on it. It was cute little Venetia Bernay, 11-year-old girl that went up to her grandfather and said, "Why not name it Pluto?" And he's like, "Okay, why should we name it Pluto, sweetie?" She goes, "Well, all the other planets are named after Roman gods and goddesses. And Pluto is considered the god of the underworld, which out in space is kind of dark and scary and cold. So why not name it for the god of the underworld?" Basically, her grandfather went, looked at his colleagues. "Well, what do you think?" And they said, "We like it. It basically eliminates all these interest groups, and we can keep with the tradition of all the other planets have the same names." And so it got named by an 11-year-old girl. So don't think you don't have some influence even in the scientific community as well, kids. In fact, one of the images for like the symbols, because over here you have one of the symbols for Pluto. One of the other symbols for Pluto is basically a P with an L marked together. The P and the L is basically the initials for Percival Lowell. So they appeased the one guy who was trying to find Pluto but couldn't find it, so they gave him put his initials into a symbol to give him the credit. So after doing some further research over the course of years and several different telescopes, they discovered that it was roughly about 1,400 miles in diameter. It's a tiny little thing. In fact, just to give you a size comparison, Pluto fits inside the United States. Yeah, it's tiny. And it's very far out there. Sometimes it could be anywhere from 29 astronomical units to 49 astronomical units, roughly several million miles away. It has a decent sized mass, so it's still massive enough to be spherical in shape. It's mostly composed of nitrogen and methane. And it's incredibly cold. The average temperatures on Pluto is negative 360 degrees Fahrenheit on average. And one day on Pluto is longer than a year on Earth. And 1 year on Pluto, meaning to go all the way around the sun, is 250 Earth years. So many of us won't even live long enough to be able to know that Pluto went around the sun once. Crazy. So the ultimate question was, did we goof? As I mentioned, Pluto is about the size of the United States. In fact, both Pluto and its moon Charon could fit in the US. Because the reason being why its size is a big deal is because, remember, we talked about something gravitationally pulling on Neptune to alter its orbit. This is so tiny, there's no way it could alter Neptune's orbit at all. So there has to be something bigger out there. It does have a moon, but it's often considered a double planet. What we mean by that is that normally planets that have moons and the moon goes around it. In the case of Pluto and Charon, they both orbit each other. And the reason being is because they both have similar mass, to where the center of gravity for Pluto and the orbit of Charon, the center of gravity between those two planets lies outside the surface of Pluto. So therefore it rotates as a double planet, rather than having the planet in the center and going around the planet. Think of it this way. Our moon is about 1/4 the size of Earth, but given its gravitational pulls, the center of gravity for the moon and the Earth still lies far within the Earth. Whereas for Pluto, it lies outside Pluto's surface, so therefore it orbits like this. It has an orbital tilt of 17 degrees. Now, most planets lie within the same plane, and they go around like this. But for Pluto, its tilt is like, it's like tilted really high, and it goes around like this. So that's why we started to kind of get a feeling like maybe it's not of our solar system, because most planets were formed in the same plane, whereas in this is not. And its eccentricity, meaning how elliptical its orbit was extremely high. as I mentioned, it takes a long time for Pluto to go around its orbit once, whereas in many of the other planets, they have some elliptical orbits, but not as extreme as Pluto. So when we're looking at the orbit of Pluto, as I mentioned, that 17-degree tilt and its high eccentricity. So the reason being why it can sometimes be the 8th planet is because it crosses the orbit of Neptune. So it sometimes could be closer in to the solar system via Pluto than Neptune rather than Neptune and Pluto. And that was one of the weird things about poor Pluto. And then we did further studies with new specialized telescopes, including space telescopes. Like the image that you see on the right was the best image Hubble could get of it. And we discovered objects that existed beyond Pluto in the Kuiper belt. We also discovered Ceres, which is a huge asteroid in the asteroid belt. We also found objects that lied around the orbit of Neptune, which we call trans-Neptunian objects. So we were finding more and more things that were very similar to Pluto, and we started scratching our heads. It's like, okay, if these all distant cousins are very similar to Pluto and we're not calling them a planet, should we call Pluto a planet? We did discover that Pluto did have several other moons, including 4 other moons, and their names are Nix, Hydra, Styx, and Kerberos. They're named after all the different unique characters from Greek and Roman mythology, where Charon was the ferryman for the river Styx, and Styx is the river that you go down to the underworld. Hydra was if you remember the Disney movie Hercules, the several-headed snake monster that was originally created by Pluto. And then Kerberos is the big, huge, fluffy dog that has multiple heads. You may have remembered him from like Harry Potter. He was called Fluffy, but it's a similar type of breed of dog. And then in 2003, we found UB313, which then was later named Eris, which is now also another dwarf planet. And Eris is bigger than Pluto. So here's just a list of some of the large trans-Neptunian objects we have discovered thus far that we've given names. And some of them, like for example, Eris is even bigger than Pluto. So should we call these things planets as well? So we had to put the debate to rest, because as we were discovering more and more objects, in fact, we've come up to roughly around about 20 unique objects in our solar system that are very similar to Pluto. Should we call these other 20 planets, other 20 objects planets, or do we have to kind of lay the line, so to say? In August of 2006, we redefined the term planet and what it meant, because we used the term planet so loosely that we didn't really comprehend the idea of what a planet was. It's like, for example, in the English language, using the term love. There are different types of love. For example, you're not going to love your food as much as you love your family. There's a different type of love. You love food in a unique sense, or you love a certain football team in a particular sense versus loving your family. You have a deeper connection with your family than you do with a football team. So in the same sense, you were flippantly using planet in a different state. So in 2006, the International Astronomical Union came together to define the term, once and for all, planet. Because in science, we like to be specific. We like to say what we mean, and that statement means something, and it cannot be have any different definitions and things like that. So we set a final definition. And that definition is as follows. It has to follow 3 guidelines. 1, it's a celestial body that is in orbit around the sun. So this gets rid of all your moons. Your moons, even though they go around the sun, they lie in an orbit around planets, not by the sun itself. So all of your moons, we can disallow. And the next category is it has to have sufficient mass for its self-gravity to overcome the rigid body forces so that it assumes a nearly round shape. Meaning it has to have enough mass to be a ball. And yes, a ball. If you want to check out my other previous videos talking about why Earth is not flat, please do so. In fact, I can leave it down in the comments below and or in a link at the end of this video. So yes, the Earth is a beautiful sphere, and it has enough mass to where it overcomes all the forces of friction due to objects, and it's assumed a spherical shape. So this gets rid of all your weird potato-shaped objects like comets and asteroids. And the third thing, and this is where poor Pluto falls out of the category of planet, it has to clear its neighborhood around its orbit, meaning there cannot be objects as big as itself in its orbit. And there are several objects even bigger than Pluto that crosses its orbit. And the same thing goes for Ceres, which lies in the middle of the asteroid belt. So Pluto was then put into a new category called Dwarf Planet, to where it fits either one or a couple of these, like most of these terms, but not one. So for example, many dwarf planets are a celestial body that go around the sun. They are round in shape. They are not cleared. They haven't cleared their neighborhood, but they aren't a satellite, meaning they're not a moon. But even though we settled the debate once and for all and poor Pluto got demoted, it still left a lot of unanswered questions. Like, what is still tugging on Neptune to cause it to not be in a perfect orbit that we have calculated? 2, is there a planet X? Is there a planet beyond Pluto that may be a unique planet that is causing Neptune to be perturbed? And what lies beyond the Kuiper Belt? What other icy worlds are there, and is the debate over? As I mentioned, even the NASA headquarters president mentioned that in his heart Pluto is still a planet, and it's striked up debate, and there have been several times where the debate has struck up again whether or not to consider Pluto a planet again. And so is the debate really over? We don't know. But to help with some of the new discoveries and some of those unanswered questions, in 2006, NASA launched the New Horizons probe. And the great thing about the New Horizons probe is that some of the instruments that was on New Horizons was made here in San Antonio. So we were discovering space from our own backyard. And it arrived finally in 2015 in the orbit of Pluto. And it had all these unique different instruments, but one of the things that I always enjoy is that it contained Clyde Tombaugh's ashes. So the man that discovered the planet got to have his ashes on the satellite that went to go visit his own planet. And that I always find touching. So basically the concept of the mission is to map the surface of Pluto and Charon and some of its moons, to look at some of the unique geology. Yeah, like one of the unique things that they have recently discovered about Pluto is its amazing history that they didn't understand. It also to understand its atmosphere. Pluto does have a tiny bit of an atmosphere, as well as to take surface looks at the different moons and the planet, as well as to hopefully go beyond. In fact, its current mission right now is somewhere in the Kuiper Belt. In fact, this is one of the beautiful images that came back from the New Horizons mission. So this is the most detailed image we have to date of Pluto, and it is gorgeous. Now keep in mind, we can only see one side. And the reason being why we haven't gotten a 360 view of Pluto, keep in mind, 1 day on Pluto is over a year. So that means it takes a while for the planet to be able to rotate well enough for us to get enough light to take an image of it. So hopefully with any good measure or any time, we can get a full view of Pluto. But we have named some of these unique different features, including Clyde Tombaugh, that beautiful heart that you see in the center there, as well as these unique structures. In fact, yeah, there are even mountains on Pluto. So to kind of talk about the history of Pluto, they believe that it was once hot. Like this was a planet that was possibly inside further close to the solar system, and then it drifted outward. Hence why it's funky orbit. Like it could have been a planet of some kind, and it either got knocked out, or it was a stray object that got close to the sun and then heated up and had a unique past in history and was once hot and volcanic, and then it fell into an orbit and that was really far away. We don't know. Astronomers are still trying to learn more and discover more from it. So this is kind of the history of Pluto and why it's now called a dwarf planet. So you may be thinking, what do I think? I think it should still be a dwarf planet for this particular reason. Science is an evolving subject, in the sense of, if you look back in our past, for thousands of years, we believed that the Earth was the center of the solar system. Thousands of years. And we took it as a straight fact. It wasn't until evidence provided much further information that people started to scratch their heads and they're like, are we at the center of the solar system? And then they presented something else, and then we did further research and realized, oh wait, we aren't at the center, it's the sun, and we are just one of these heavenly bodies that go around the sun. So that shaped our view of the solar system. And then as we further discovered our place in our galaxy, we realized we weren't at the center of the galaxy, but we were just one small little blue marble going around billions and billions of stars in the center of, around the center of the galaxy. And then we got demoted even further, where our galaxy wasn't the center of the universe, and we were just one of millions and millions and millions and millions of galaxies in our vast cosmos. So as we had better technology, as we had better information, our view evolved. And the same thing happens here. That's the great thing about science. Science is not stagnant. Science evolves. It changes its processes, it molds with new information, or new technology becomes available to learn new things. And so it keeps asking those questions. Okay, given this new information, what do we know? And that's why science is so amazing. It's that it's not just hard facts, but it's facts with proof that has consisted over long periods of time, and it continues to evolve as we get more and more information. So that's why I believe that Pluto should be considered a dwarf planet, is because our view of Pluto, with the new information that has come about, has changed. And I know there's been some heavy debates of like, oh, we should consider Pluto a planet again, but is those debates based upon science or personal feelings? I don't want to think of basically having science being altered because of personal feelings, but rather the facts that are presented, not interest groups. And I know sometimes that's how science does evolve, and it's kind of sad when it does. So I'd rather let the facts speak for themselves, so to say. But that's my opinion. If you want to leave your opinion, like whether or not Pluto should be a planet and why, leave it down in the comments below. If there's a topic you would love for me to cover over, I would be happy to as well. And obviously, if you are looking for something fun to do for your kids, we have futureredditsa.org that has a badge system to where your kids can learn unique things over the course of the summer and entertain themselves while getting badges and merits. So check that out. I'll leave in a link in the description below as well. So until next time, stay safe, stay healthy, and as always, never stop learning.